All right, what's up, everybody? And the people who are outside and already feeling missing out, like what the hell is going on? So as you will be, as you should expect, this is going to be high energy talk. I know it's difficult after a whole day of conference and a whole day of awesome content. And it's already, what, like two more talks, like mine and Vitaly? Okay, perfect. So make sure you stay for the next talk. Next talk also is going to be awesome. Before I jump into presentation, and we'll be talking about different stuff, and also don't close the door. Let the other people to hear me speaking, and they might be coming in. While we have a light, and I want to see how many people using Kafka today. I just want to confirm that this is not going to be Kafka 101 talk. Second question, how many of you using Kafka with more than one language? For example, you're running this with Java and Python, or Java and Node.js. Okay, few people. Who running like a full-blown, how we call it, polyglot enterprise, where you can allow every language to interact with Kafka, even Haskell? All right, one person. Which, how many languages you use? 7? You see, it's not difficult to count 7 languages, right? Yeah, this is awesome. This is awesome. Many of you probably started your Kafka journey because Kafka is generally speaking written in Java, and many Java developers kind of start using Kafka first because there is like a first-class Java style API for this, and everything is great. You have your objects using default serializer, deserializer. You ship this into Kafka topics, and it's just a brilliant golden days. Your microservices, as you can see here, they are drinking coffee and stuff like that. So they are talking with the same. I need to figure out if I'm in the light because it looks like this thing is not moving. So everyone talking same language. And we know and love that Java serialization is the best, right? It's the best thing that we have in Java. It's fast, it's super compact. We can share our Java objects across different languages, right? I'm trying to keep this energy going. Try to argue with me. No, it's not. It's super slow. It's super bloated, and also it's not possible for you even share these classes between different versions of Java. If you will be compiled with different versions of compilers, you might not be able to recreate those Java classes. Okay, I think I need to bring more energy because I don't want to lose you until the end of this talk. So everything speaks same language. It's cool, but it's not. Until the point where someone came in and saying, "Hey, great idea. Go language. Let's rewrite everything as Go. It's cloud native, runs great in containers. Let's rewrite it." And all of a sudden, your front-end developers are like, wait. We know JavaScript. We don't want to know any Go. So in this case, let's rewrite the services in the Node.js. So we're getting into a situation where they need to start communicate. And we're coming into this moment where there's multiple space nations that they try to communicate to each other through some common interface. And since no one can talk, because obviously Java objects cannot be parsed in Python and JavaScript, even though Java and JavaScript, that close, right? That close, but still no, you will not be able to parse Java object in JavaScript. We're going into this chaotic biblical story of Babel Tower. But there is a hope. And this hope, I don't know how many of you read the Hitchhiker Guide to Galaxy and got the reference about Babel fish? My people? No? No? Okay, few people, nice. Okay, so at least few people got my idea. So there is a hope. So from Tower of Babel to Babelfish. That's how I called this presentation, where I will pay a little bit more attention that it actually requires much more attention to the subject of metadata, your data contracts, about how your services would communicate to each other without breaking each other, but because we want to communicate efficiently. So today we're going to be talking about Schema Registry. Anyone using any type of Schema Registry these days? It can be Confluent Schema Registry, Red Hat Registry, maybe Red Panda or whatever. Great, awesome. So few people are aware, but the rest of the group will be amazed, I hope. My name is Viktor Gamov. I work as a principal developer advocate at a company called Confluent. Anyone heard about Confluent? All right, so Confluent was a company that founded by original creators of Apache Kafka, so we know a few things about Apache Kafka. Myself, I wrote a book about Kafka, so I can also say I know a few things about Kafka. I'm also Java champion. It's kind of, every 4 years we have this like a Java Olympic Games, and we need to fight different Java champions, and this is how you become Java champion. It was a joke, because we are in Greece, and I thought joke about Olympic Games will spark some joy. Anyway, so Java champion, I do a lot of in Java community, so I'm working with Java developers, but also I realized that there's a lot of things that can be spread across multiple different languages, so that's why the subject of finding the common ground between different systems that talk to Kafka is very fascinating for me as the person who advocates for Kafka. Second most important slide. Yes, all slides and all materials, including links, including video, we're recording, and we're recording over there. And everything will be on this website, speaking.gamov.io. And you can find some other presentations if usually they also come with video and stuff like that. All right, I'll give you 3, 2, 1. Now, if you had the chance to read the Hitchhiker Guide to the Galaxy, you know that if you're not, so I will tell you anyway. So there was a special device that's called Babel fish that you need to plug in your ear, and now you will be able to listen different the species will communicate. So the Babel fish, in our case, we're going to be proverbial Babel fish. In our case, would be Schema Registry. I will be talking about Confluent Schema Registry, everything except maybe some of the API discrepancies, maybe also applicable to other implementations of Schema Registries. Majority of them just use same API as the Confluent Schema Registry, and it should just work. This Babel fish will be helping us to establish communication between multiple services. I will be highly advocating for particular format, specifically Avro, but support for popular protobuf and even JSON schema is also available. There is some. In general, in principle, they all have the same ideas, but there's some details the way how they're dealing with the schemas. And to help me today with this presentation, I will be using some of the applications. So I will use my order servers, and this order service will be shipping different type of orders into Kafka topic. I will have a inventory service that would be reading this data from Kafka topic and doing something with this. In this particular case, we'll just reserve a products that our customer ordered through this order. And for backend people, for my Node.js people, there is analytical system that will be reading data about orders and display this information, how much money we get. So in this case, typical microservice scenario for you. And I'm going to head and start. I'm starting my first order service. Next, I will start my inventory service. And sorry, it's important. It's the best pictures I'm getting from all DevOps conferences. So I need to do this. So, and I'm running the analytical service. Also, in the background, I do have 2 things running. It's my Kafka in my Schema Registry running in containers. Again, same thing works with any implementation of Kafka. If you're running MSK, if you're running Confluent, everything will work similar because Kafka is becoming a kind of like a protocol of communications. Now, I have a few examples. In the very beginning, I'm showing you how things would look when everything is terrible. Obviously, our order service will send a Java object in the Kafka topic, and the JavaScript and Python would need to read this. And I'll just do demo 1. So in this case, I will send a Java serialization object, and we'll see if the other services will choke off this. Obviously, they should. So the Java, everything is great. There's no errors. Let's take a look on the front end for our inventory service. Inventory service has one error. And this error would be here saying, receive the matches that appear to be Java serialized, cannot deserialize. Because it doesn't know actually how the Java serialized bytes look like. And Kafka doesn't care about how your serialized bytes would look like. No one cares, except you as a developer. You need to care about the structure. So you can send Viktor, but we have a JSON. Like why we need to use anything else? JSON is awesome, right? JSON is great. It's human readable. That's what we were telling each other for a very long time. It turns out that it's too good, because there is too much freedom in things what you can express in JSON. Yes, there is a ways how you can be kind of like a more contained about what you want to express there. But still, in the end of the day, JSON has fundamental flaws. It's too bloated because you are building the schema inside your object. It's text. You can have some mistakes between different field names. One of the examples that I have in this particular case is that there's some of the JSON naming field inconsistencies actually failing in my demo, because one of the systems will report this error. So let's see if an analytical service is working. Yes, so it received two objects. One is in a JSON format. We receive something. So looks like JSON can solve some of the problems. But again, we want to have something better. We want to have something that would allows us to have very stable communication between the systems. So that's the premise. Now, we discovered this great idea of having schemas stored in Schema Registry, and we decided to choose the Avro format. So Avro was designed as a format that. So first of all, the protobuf, it was developed at Google and used heavily in Google. And it was open source at the time when there was a requirement in Hadoop systems to have some sort of serialization format. That also won't suck, because Hadoop is also happened to be written in Java. So they tried to see whatever existing systems and the serialization or deserialization systems or encoding, decoding available. They tried protobuf, and protobuf didn't fit their needs, so they come up with Avro. So Avro is much more compact. It has a schema that can be described across two actual languages. One, they also consider human readable, called IDL, that you kind of like using some sort of DSL. And the second one, the Avro schemas that I personally like to use, is described as a JSON object. JSON document. But so you can do multiple things with this. So another interesting thing that happened when you're using this the deserialization systems like protobuf and Avro, they also come with some sort of tooling, because they taken care of translation from your schema, which is human readable. You can communicate about the schemas. It's a text. You can use diff. You can use git, and you can store those schemas there. But at the end of the day, you want to have some sort of artifacts that you can use in your application, right? So in this case, they're providing tools for generating code from the schema that would be platform specific. So apart from getting a very compact format, getting a very efficient serialization cross-platform, we're also getting ability to do some sort of like syntactical part. So for example, in Java, we're gonna get compile time errors if we try to use some properties which are not available. There's no classes, or there's no other libraries. In other languages, you can do this in runtime. So you can do schema validation on runtime. So this is pretty cool. And also, they're strongly typed. Now, my demo again runs right now into Docker system. I already showed this. This is how we describe our Avro format. We have our order information where I have type, name, and different fields. I also can define the namespace, so that would be translated into some sort of like a package schema in Java, for example. And this is something, as you can see here, I use this illustration of some sort of like a monks who are kind of like look into this one. And this is kind of your data council. Every time when in your organization you're trying to agree about how you're going to be exchanging this information, this is kind of like, it's not the technical aspect. It's more like organizational aspect, how you would communicate changes in those schemas. And when you publish this into Schema Registry, you can, different tooling can enforce it. We're using this internally in Confluent Cloud to enforce some of data contracts across multiple components inside inside our Kafka cluster. But in your organization, you can use it for different purposes. Now, one of the things that people don't know, maybe. So Schema Registry also uses Kafka as a storage, but also it exposes REST endpoint for accessing those schemas. You can register schemas, you can get the list of schemas available, you can get all this information from this endpoint. So let me quickly show you how this would look in. So I'm running this inside the Docker, and I have my Kafka cluster and the Schema Registry running inside the Docker. And since the Schema Registry was connected to my Kafka cluster, it automatically created this topic of schemas. If I will go ahead and see messages inside the schemas, I can see there's a bunch of interesting things already available. So you can disregard this for this particular presentation, but in general, this is how this would look like. I probably already registered a bunch of stuff here, so I need to clean up this somehow. And inside this key value for this particular topic, this multiple versions of schemas will be stored inside the Schema Registry. So, and for you as a developer, you will have like a REST API to talk to the schema. So let me show you a normal flow of data if services decide to use Avro. So first of all, I don't need to change my application because my application is already prepared. I have just two different consumers that will consume from the same topic. And with this, I have a demo, the number 2, that specifies a normal flow of the messages. So my order service will receive this message, and after that pushes inside the Kafka. We have an inventory service that will be reading data and try to register our product, and we have analytics. So you already know this. And this is how this would look like for an analytics service, and this is how it would look for same order ID we have here. Just let's see if it refreshes in a second. We should get same order ID. Yes, so same order ID A1, 6, A1, it's all here. It's JSON. Let me see if it's actually, no, it should both connected, both working fine. So I should get the correct product information soon. From perspective of what's happening inside the Kafka topic. So I have an orders topic where I previously had unfortunate case of having Java serialized object here. And this is just how it's represented in this the extension that shows messages inside the Kafka. But in real life, it looks much worse. If you ever try to open .class file, this is basically what you will see. Now, because Kafka broker doesn't have anything from preventing you of submitting different type of data in the same topic, at least without Schema Registry, there's a bunch of junk already available in my Kafka topic. But the one that we're actually interested in, the one that has a data format says Avro, and it has this information about, oh, can you see it? Okay, let me scroll this up. So some metadata about this value is the schema ID 4. So this is the way how our clients will be able to figure out which schema to use. When you receive message from Kafka topic, this deserializer will read first few bytes of this payload and saying, okay, this is schema ID. I can use this schema ID to fetch schema from Schema Registry, and after that, I'll get this information. So if I will go to my Schema Registry and show whatever schemas are available, so I would see this orders value. This is convention that used name of the topic and its key or value. So because you also can use serialization to serialize your keys, you can have a different serialization between keys and values. You can have a string keys and arrow values, or you can have arrow everywhere. And schemas, I have this ID 4. That the schema is available. And the schema would represent, how my application would look like. Okay. Now, so we get the understanding, right? So we have 3 services. We have a schema registry. We have Kafka. That's how our architecture would look like. Now, so once you already have these facilities inside your applications, now you can do some interesting things. For example, those schemas can be registered by some council that would be responsible for data contracts. And this information can be automated. So this process can be automated as a part of CI/CD pipeline. So schemas are text, or you can create a pull request where all discussion is going to happen between different involved parties. So they would agree how the things would look like. They would agree about the compatibility and what's the different rules will be available to make sure that future generation of applications will be able to read like old data, and for example, old generations of applications still will not be broken if new data will arrive. So they can talk all about the things, and also baked into some sort of automation pipeline. Now, this is a good time to talking about changes. So first of all, let me show you how this would look like if I would update a schema. So in my applications, I do have a folder schemas, and we're using every application right now uses this version of schema. So what I would do, I will take this, which is going to be my updated version of schema. I'm adding few properties here. So let me show you what's the div here. And one of the things that you will see here, we added the order timestamp, and we added metadata. And also we specified some the types inside this, because additional metadata is going to be just a generic map, including some additional things that we potentially might need. And so let's see how this would change what is happening with our application. So if I go into my order service, I update schemas here. And also, if I would, where's my Gradle? If I would run this process to regenerate my POJOs, oops, doesn't, okay, so we'll do this manually. Make build. So what's going to happen? This process will read the updated schema and created artifacts for your language. It creates the TypeScript class, creates the class in Python, and change the thing in Java. So the way how this would look like, if I say will be in, where is it? Say inventory service, we have SRC generated, and this is where we're getting our order event information, for example. So for some reasons, it's still not, it's not there. Didn't generate correct one. It should. We'll see if it's the after build. Okay, so it passes here. Let's see. It says runs build is correct. So with a different target. So now it should be updated. Order service. No, it's not. Did I update it here? Version 2. I can take this from here and move it here, because I already have a path that is predefined, so I don't want to mess this up. So in this case, if it runs, so now I would have order entry that will have information from the schema too. You see, even this compiler also brings comments from the section inside the schema, so you would know that something that happened here. So with this, I either recompile my applications, or I can demonstrate you some of the things. For example, I keep running my Python application, so let's assume that that's kind of like a previous version, so they're still using old schema. And I'm going with the updated version of my order service that would use new schema. So I would simulate a situation where we need to have a backward compatibility between new version of producer and old versions of consumers. So if I will go with the happy path, so what's going to happen? Every order process, we're going to be looking for 7EE order. So 7EE orders here in our inventory, and 7EE orders here. Even though I change schema, and I will show you that if I go to my orders topic and get the latest 7EE key, that's my object that I just sent. And as you can see, come on, small screen is so not easy. Okay, let's see. Okay, where is it? Yeah, as you can see here, because none of my producer, I didn't change the code, I didn't add this information on the Java side, so it used this as use some default values. Now, for the case where I can introduce some of the breaking changes, so I will just show you. I'm not gonna. Oh no, we have time. So we do have time. So in this case, I'll show you some incompatible schemas that we can also introduce, and this is something that needs to be configured on the schema registry. By default, before I jump to there, let's see if I have a slide for this. Let's talk about this. Yes, I do have a slide for this. Now, so there is a convention that human decide to communicate how they're gonna be supporting changes going forward. So we have a backward compatibility, meaning that new versions of applications still will be able to create the good stuff for our old application. So in this case, by default, what things that I just changed in my application, version of producer were changed, and I'll show you this schema, how this would look like inside Schema Registry. But I still will be able to create the payload that will be available for clients. How it works. So in Avro, we have something that's very unique. It's called two types of schemas. You can define a read schema and write schema. So you can, even when you will be reading information, you can overwrite what kind of schema you will be using in order to consume this. Avro is very cleverly organized as a binary thing, so everything is navigated through certain offset. So with Avro, you will be able to read even from different places. So like if inside this like a binary array, if you move the properties in a different location, in a contrast, if you will be changing tag indexes for your protobuf, anyone familiar with what I'm saying? So in the protobuf, you cannot define kind of like arbitrary properties. You need to specify position in which this particular, you will have a first name, position 1, last name, position 2, address, position 3. So you need to be explicit about this. With the Avro, you don't need to do this. It works out of the box. Now, the forward compatibility, when you are updating consumers with new versions, but they also still be able to read the new version, you also need to read the version of the producer from the previous version. Now, and also there is, when the both situations are connected, so we have a full compatibility. And you can, it's kind of a rule that you can configure in your schema registry to enforce certain behavior. Specifically, specifically, I do have example where I am running make demo 4. Oh, before that, let me show you. Inside the schema registry, since my application now produces in a different version of schema, in my applications consume with different versions of schema, so I can go ahead and say, take this schema, select to compare, and we'll take compare with selected. Now, so with this div, let me open full screen, scan it. With this div, we can see that's a different version of the field. So we can compare comments, what was added, and all kind of stuff. And again, the way how the application would know it's the ID, the schema ID, how they will identify. They read message from Kafka topic, read the first byte with get schema ID, get the schema, and perform all sorts of validation. Now, in demo 4, I will try to register some of the schemas that are not compatible for some reasons. So, for example, first time, I'm trying to register field where are required for full compatibility. In this case, I'm increased just to demonstrate you how this registration rejection works. You talking to just REST API or through the plugin through CI/CD and trying to execute a schema registration, and even force schema registration was not available. So schema registered being incompatible with early schema for same subject. So subject, as you already know, it's the topic name plus value. It can be a different subject for topic name dash key and so far so on. So we're trying to register the schema for a particular subject, and it has something that will be incompatible between them. So you can do stuff like this. If you can enforce some of the incompatibility here. So for example, you can field removal plus addition. In general, if you don't really care about full compatibility, you can opt out either for forward compatibility or backward compatibility. In backward compatibility, actually, all these things with the field removal and addition, they should still work. All the applications will be able to read data that was produced by new version. This just will skip the places where it doesn't know what to read. But because I wanted to show how the actual system works, in this case, some of the minute and small change in the schema prevents it from to be registered, which is a cool thing. It's kind of like something that a tool like a schema registry will prevent you to do some of the crazy things. Now, with all this, we do have a little bit of polyglot harmony, right? Did I at least made you interested in exploring this type of subject? Or is it, we're fine. We're gonna send them Java and see how they're gonna be crying. I highly recommend you to consider looking into Avro and have a centralized schema control. It is will save you some time in the future. So now it is also not something that you kind of technically doing. It's like a DevOps, right? DevOps, it's not the person. I hope you know. It's a piece of culture. It's kind of the way how the process would be. You have a platform engineer or DevOps engineer, God forbid. Schema governance, same thing. It's not a human. That's not a person. It's a process. The way how you treat your data catalogs, treat your data products. Some of the kind of information from schema registry can be propagated to other places like data catalogs inside different systems. That's some of the things we do internally in Confluent Cloud. Like if you have a message that has proper schema, so automatically some stream processing capabilities would be much easier because you know how to infer structure of your data and how to do some of the things with this data. Also, you can prevent say you can have a server-side component inside the Kafka that will be preventing applications to produce messages that would be incompatible from day one. So it's a part of the processes, what you want to imply in your system, or it's in the part of the process automation that will be performed as a part of this type of procedure. Schema registry is core infrastructure for many, very similar. I don't know if any of you writing microservices with REST services and not publish OpenAPI spec. Who this? I'm expecting no one. Because this is what we do, because we want people to use our services, so that's why we need to share this like a Swagger information or like an OpenAPI spec so people would know how to invoke our service. Same thing if you are already transformed the organizational mentality from request response to more event-driven, so that's your protocol, that's your kind of like open API specification that you actually need to be complied with because these people want to use your system. And with this, my name is Viktor Gamov, and as always, have a nice day. I'm open for enhanced interrogation until 5 more minutes. Thank you.
Are there, okay. Are there any questions you would like to ask?
When there's quiet in the room, there's two things. Everything is clear or nothing is clear. And since you're quiet, it's very difficult for me to understand which one is which. So if something is not clear, please shout out. There's a gentleman over there
right.
with beautiful haircut.
Yeah, okay. Actually, I have two questions. One is a trivial. Why, if Schema Registry supports gRPC as well, and not only Avro? Yeah. And the second question is, nowadays there is the trend, I think, to hide Kafka and, let's say, expose the interface via REST. And I was wondering why that could be the case.
Perfect. Amazing question. So first of all, Schema Registry doesn't support gRPC, but we do support protobuf. So gRPC, it's the cross-platform like RPC protocol that involves description of interfaces and description of payload. So we do support protobuf as a description of the schema. But for example, in Avro also there's like RPC mechanism. Second question is that why hide Kafka behind some REST service, right? So it's so beautiful. Let's show this to the whole world. So here's the thing: Kafka. It's your core infrastructure. It's your middleware. You never expose your middleware to your consumers. You always putting some sort of layer on top of this. You never put your MQ in saying, hey, like whole world. Take your mobile application and start writing this into my RabbitMQ or whatnot. So Kafka would be a layer that would be performing communication between your services. Now, why? I'll give you two examples where you can have, it's a good thing to have REST endpoint in front of Kafka and the bad thing. Now, there's some situations where you need to deal with the languages that don't have a native support for Kafka. For example, Bash. So in Bash, there is no native library that you can talk to Kafka protocol. However, if you're using some sort of REST proxy, you can call this like Bash scripts and they can call your Kafka. Would it be efficient? No, I don't think so. Very early days of JavaScript client and Node.js client, it didn't exist before the community started putting too much effort into building too many clients. So because there's like 2 different clients from community and 1 Confluent developed for JavaScript. And a lot of Node.js application, they would talk to REST proxy in front of Kafka to communicate. So the answer for you, it really depends of what you do with Kafka in your organization. Usually, you still have some sort of microservices in front of Kafka in order to serve this. So that's why my consumer has some sort of UI. So that would bring data from REST endpoint. Does that make sense? There's a gentleman over there. You can try to shout. That's okay. And the second question? You're trying to produce messages into Kafka topic through some sort of UI? Very good question. Very good question. Yeah, I got you. Yeah. Correct. Yeah. Perfect. So the question was what kind of like UI I'm using to talk to Kafka. This is something that we developed with Confluent. It's open source, available for any Visual Studio Code reincarnation. Just too many of these days, right? So if you're running this in the classic Visual Studio Code, you will be able to run this. If you run in Cursor, Windsurf, I'm running this inside the Kiro. It's Amazon editor that I kind of like it these days. So it's free, available for everyone, and you can connect any type of Kafka. Not only Confluent, not only Confluent Cloud, open source. In this case, I'm using my connection to my local Docker and stuff like that. So for the second question was, the gentleman was trying to read the message from Kafka topic or produce it. I think he was trying to read, because when he reads some sort of serializer, deserializer application throw the error about the magic byte. So inside these libraries around Schema Registry that we built at Confluent, and there's some community support on this, there's a special type of components that you need to include in your application. In Java, it's called serializer, deserializer. In different systems, it can be marshal, demarshal, encoder, decoder. Same thing, like potato, potato. So, and you need to use special components. In the case of JavaScript, for example, we have package dot. Where is it? Where is the JavaScript? Or in case of Python, for example, in this case, it includes client. It also includes information library to do with the Avro. For Java, you need to include something that we developed at Confluent, specifically libraries for Schema Registry. Where is it? Yes. So, for example, this library would be included. So this library adds this special magic byte. So you can read the content of this from the Kafka topic. It's still possible because Kafka doesn't care about what you store there. You can store images, but don't, please. And if your client doesn't know how to read this, or maybe some UI, for example, the Kafka UI, the one that I use, actually knows how to read the messages that inside Kafka topic, and they understand this is Avro. And this is where they read this information. They read this information from Schema Registry. So some of the tools can discover something. Console tools that you probably use doesn't know. Usually also it happens between discrepancy if you're using open source Avro serializer versus Confluent Avro serializer, because open source Avro serializer requires explicit schema and needs to be shipped together with. In our case, it doesn't require it. It's stored already Schema Registry. All right, I think we are done. I'm available for if you want to ask some other questions. But the next presentation will shock you. Stay.
Thank you very much.
Thank you.